So we have discussed about binomial distribution. The next distribution is nothing but Poisson distribution. Poisson distribution is a limiting case of binomial distribution. It means that by imposing some conditions on binomial distribution, we get Poisson distribution. So we know that we write binomial distribution in this way, where x is a random variable following a binomial distribution with parameters n comma p, where n is the number of trials, p is the probability of success. So when do you call this? When this binomial becomes a Poisson means by imposing conditions on these two terms called parameters of binomial distribution, it approaches to a new distribution called Poisson distribution. By imposing or by putting some conditions on the parameters of binomial distribution, a new distribution is derived, which is called the Poisson distribution. Okay, so let us see what are those conditions on the parameters. So whenever n is very large, okay, whenever we wrote that the PMF or the probability function for binomial distribution as p of x is equal to ncx into p power x into q power n minus x. When there we wrote x is equal to 0 to n finite. Whenever n is countable, okay, that distribution is called binomial. So in all the situations n may not be finite. Whenever n is approaching to a large value, and what is p called? P we call as the probability of success. Okay, whenever this p is very small, okay, whenever this p is very small and n and p is equal to m, a finite value, under these three conditions the binomial distribution changes its form and turns into a new distribution called Poisson distribution. So those three conditions are n, whenever the number of trials is very large, and p, the probability of success is very small, and np means the mean of binomial distribution is finite, say m. This Poisson binomial distribution will approach to a new distribution called Poisson distribution. Okay, so this Poisson distribution we indicate with p, and here you will find only one parameter called m. M is the parameter in Poisson distribution. So we have under binomial distribution, okay, the PMF as we wrote p of x is equal to ncx into p power x into q power n minus x. Under these three conditions, under the above conditions, okay, under the above conditions, this p of x changes its form into p of x is equal to e power minus m power x by x factorial, where x is equal to 0, 1, 2, 3, so on. Okay, so binomial distribution under the three conditions called n turns to infinity, p is very small and np is equal to m, it gets new form or the new conditions, and the distribution so obtained is called Poisson distribution. Under Poisson distribution, the PMF of by putting these three conditions, the PMF of this distribution will changes into a power minus m power x by x factorial, where m is equal to np and x is equal to 0 to so on, 0, 1 to so on infinity. In binomial distribution, x is from 0 to n, here x is from 0 to infinity. So here also you have two types of problems as we have discussed for binomial. You will be given a question directly to fit a distribution, and other one you need to find out the probability. Now let us discuss those two types of problems here. So I am considering the first model, which is nothing but not the fitting of Poisson distribution, another kind. So in page number 267 you will find that it is known So it is given, it is known that from a past experience in a certain industrial plant, there are on an average, okay, on an average 4 industrial accidents per month. Okay, find the probability that there will be not less than 4 accidents, and assuming the Poisson distribution. So, assuming it is given to assume the Poisson, by assuming Poisson distribution, you need to find out the probability that there are less than 4 accidents in that industry. It is also given e power minus 4 is equal to 0.018. So, whenever we have two types of categories like success and failure, we said that the problem comes under binomial distribution. So if you go after say in page number 266 and 265, you'll find the applications of Poisson distribution. Just go through that. From that you'll be able to understand where we are going to use the Poisson distribution. So Poisson distribution mainly used whenever the p is very small. P means whenever the probability of a particular event, so called success, is very small, we can go for Poisson distribution. Here the event under study is nothing but the number of accidents in an industrial plant. So I think if you consider any junction, okay, where two roads meet, we observe that number of accidents are very small in a large interval. So there is a chance of accidents is, whenever we have the chance for a particular event is very small, we can consider that as Poisson distribution. To get more clarity, just by reading you'll be able to understand that. Read to page number 266 where we can find the Poisson distribution. Coming to the present problem, it is clearly given that assume Poisson distribution. I think no confusion at all. Here in the question itself given that to use the Poisson distribution. So as the question itself given it's a Poisson distribution, we write that with Poisson with m. Okay, what is its probability function? E power minus m m power x by x factorial. Okay, where x is equal to 0, 1, 2, so on n. Now it is given that in the question it is given that there are on an average 4 industrial accidents per month. Whenever we use the word called average, I think average stands for mean. Average and mean are same. Whenever a word called average or mean is used, we can directly take that as m. So m here is nothing but 4. Whenever they in the question, if it is not specified clearly average, then you need to calculate the average which represents m. Again I am repeating, it is clearly given that use Poisson distribution. Moreover, it is given that on an average 4 industrial accidents means average means m is directly given to you. The other case where average means m won't be given, then you are going to calculate m. In present problem, m is directly given to you. You need to calculate probability that number of accidents is less than 4. Less than 4 means maybe as x is starting from 0, maybe x may be 0, maybe x may be 1, maybe 2, maybe there may be 2 accidents or 3 accidents. Means it's not a particular value. Find the probability that there are 4 accidents means only P of X is equal to 4 you are going to calculate. If they are less than 4 means that may be 0, 1, 2, 3. So you need to calculate P of X is equal to 0 plus P of X is equal to 1, P of X is equal to 2 and 3. What is P of X? P of X is e power minus m power x by x factorial. So if you put x is equal to 0, you will get e power 0, m power 0 by 0 factorial. E power minus m power 1 by 1 factorial. E power minus m square by 2 factorial. E power minus m cube by 3 factorial. You also know the value for m. E power 0 is nothing but 1. This entire term is going to be 1 as this is 1, this is 1, 0 factorial also 1. E power minus 4, m is 4 here. I am putting all the values. So here you have e power minus 4 can be taken. This is e power m. So this is e power minus 4. If you take out e power minus 4 common from all, you will get 1 plus 4 by 1, 4 square by 2, 4 cube by 3 factorial by means 6. E power minus 4 is also given to you 0.018 and into you simplify this value. I am writing the value directly 0.4332. In Poisson distribution always the e power minus 4 values will be given to you. So this is another type, first type of question in Poisson distribution. As I said you that you will have another type also where the average is not given to you. In the same page you have another example. So if 5% of what I said in Poisson also you'll have 2 types of problems where a direct question like fitted by Poisson distribution. So that is second category. Here if you read the question, if 5% of electric bulbs manufactured by a company are defective using Poisson distribution, I think here also not need to confuse. Here the question is given on Poisson only. Using Poisson distribution, find the probability that in a sample of 100 bulbs, none is defective and 5 are defective. So you got the first clarity that you are going to use the Poisson distribution. No doubt at all. So X follows PM. So you write its PMF also. What is its PMF? E power minus m power x by x factorial. Now you should identify the given data. Is there any word like average or mean? In the previous question, the average number of accidents per month is given. So we have identified m directly. In this question, no term related to average or mean is given. Moreover, 5% of electric bulbs are defective. So whenever you are given with percentage, that represents the P, which is nothing but 5% here, which is nothing but 5 by 100. You know that probability should always lie between 0 and 1. Now you need to calculate m. To do anything or to calculate this bit or this bit, first of all you should identify this m. If m is known to you, you can calculate any one. So any bit given in the question. In the previous problem, as m is directly given to you, you have substituted and you went for calculations, whereas here m is not given to you. So you should calculate m in the first bit. To calculate m in the first bit, okay, so while writing the conditions we wrote m is equal to np. We wrote that binomial as a limiting case of Poisson distribution. We took three conditions. What are those three conditions? N turns to infinity, p is small, and mean np is equal to m. So m can be calculated by using the formula np. So p is known to you, and also in the second line it is given that find the probability in a sample of 100 bulbs. So n here is nothing but 100. So 100 into 5 by 100, which is nothing but 5. So you have calculated m. So m is not given to you. M stands for average. Average can also be calculated using the formula n into p. So you should identify what is p and what is n. Here 5% stands for p, and n, the sample size, is n. So what is the first bit you need to calculate? Probability that none is defective. None is defective. None is defective means there should be no defectives. So you need to find out probability that when x is equal to 0, e power minus m, m power 0 by 0 factorial, these two are 1, e power minus 5. The value for e power minus 5 is given to you in the question itself. So that stands for the answer for this first bit. Second bit is nothing but probability that there are 5 defectives in the 5 defectives. So means you need to find out exactly 5. Means e power minus m, m power 5 by 5 factorial. M is also 5 here, e power minus 5, 5 power 5 by 5 factorial. Okay, you simplify that. E power minus 5 value is given to you. 5 power 5 value is 5125. 5 factorial is 120. After simplifying this is nothing but 1823. So these are the two types of problems in the Poisson distribution. Thank you.